Namaste, welcome to Adharva Nava. I am Sirisha and I teach mathematics and physics for CBSE, ICSE and IGCSE grade 6 to 10. To follow my classes, kindly subscribe to Adharva Nava, hit the bell icon for further notifications on different topics. Kindly share, comment to help others as well. Thank you. In this course, we will learn about rational and irrational numbers, which come under the category of real numbers. We will see the classification as well as the properties of rational numbers and decimal number system, and further into irrational numbers, surds, etc. Let us explore more. Let's understand the concept of rational and irrational numbers. First of all, we need to analyze the number system. Let's start writing. Real numbers is from where we understand. So real numbers are represented by R, and the real numbers are categorized into rational and irrational numbers. Now we need to understand how does a rational number look like. Okay, so rational is represented with the Q and irrational is represented with the Q prime or a Q bar. Both are the representations of irrational number. It's just the prime value of Q. I can say it's just like opposite of rational condition. So further we analyze what should be the condition of a rational number. For a number to be a rational number, it should be in the form of P by Q. A number in the form of P by Q where Q is not equal to 0 and most importantly the HCF of P comma Q is 1. What is HCF? Highest common factor, which means P should be an integer and Q should be an integer. Both should be integers. So P comma Q belong to integer set. They should belong to integer set, but only thing is they can be any integer, not a decimal, but the condition is HCF of P and Q should be 1, which means, say for instance I write 5 by 9. Take 5. 5 belongs to integer? Yes. 9 belongs to integer? Yes. So the next condition I should check is 5 and 9. What is the HCF of 5 and 9? 1. 5 has the factors of 1 comma 5. 9 has the factors of 1 comma 9. What is common between them? Only 1. So 1 is the HCF for both the numbers 5 and 9. So in that condition I can say 5 by 9 is a rational number. So do you understand? The conditions to be satisfied is number 1, P by Q form where Q is not equal to 0. We will come back to this part a little later. But first understand that it should be in the form of P by Q where P and Q belong to integer set and HCF of P and Q should be 1. Why not Q a 0? We will discuss that. Okay. And the second should be a rational number. A rational number should have these conditions to be satisfied. And the next one is irrational number. Irrational number, usually the set which comes under irrational is surds. First of all, what is a rational number? The number which is not a rational number, the number which cannot be represented in the form of rational number can be called as irrational. It is just simple as that. Okay, let's consider some examples. Pi. Pi value is 3.1415 and so on, it goes on. It's not stopping. Neither it's repeating. What do you call these kind of decimals? Non-terminating and non-recurring. So these kind of numbers or decimals come under the category of irrational numbers. On the other side, if you find rational numbers, you can see the decimals which are actually either terminating. One is they should terminate. Example, you can find example being, say for instance say 9 by 2. 9 by 2 is 4.5, that's all, it stops there. Okay, let's say 13 by 2, so it is, or 135 by 2 maybe. Okay, 2 6 are 12, 15, 7s are 14, 0.5. See, it's stopping at a point. Say for instance, another example is you can consider 4 by 5. Yeah, so if you divide 14 by 5, you take anything you can take. It's 5 2s are 10, 4 left, point you keep, 40, so 2.8. That's how you get, isn't it? There's terminate. They terminate means they stop. Terminate means to stop. Okay, terminating means stopped. There is a stop for the decimal count. Okay, and then the second category which comes under rational numbers is, this belongs to rational numbers only, which are non-terminating. They do not stop. Non-terminating itself means they do not stop, but recurring. Recurring. Say for instance, you get a value of say 10 by 3. 10 by 3 is how much? 3.3333, so on, it goes on. 3.3 bar. You must have learned this in previous classes, isn't it? So there is a termination, then it's a rational number. It can be a rational number. There is no termination, but there is repetition, then also you can come under the rational numbers. We have methods to convert this into rational numbers. So overall, I can say that a rational number has this pattern of P by Q. Now, why am I categorizing these decimals under rational numbers is, even though it is terminating, I can completely turn this 4.5 back into 9 by 2 form, or I can convert this 3.3333, which is repeating, recurring, non-terminating decimal, into again a rational number form. You can see very clearly that I have produced this decimal number from a fraction, isn't it? So obviously the vice versa is possible. So these also come under the category of rational numbers apart from these. Okay, right now if you check 9 by 2, 9 and 2 have the common factor of only 1. If you take 135 and 2, still the same. 14 and 5 still have the same. It doesn't mean that it should be an odd number always. See this example, you can say 14 and 5, one is an even number, one is an odd number. That doesn't matter whether it is even or odd. It only matters whether your HCF between the numerator and the denominator is 1 or not. That's all. Okay, so 10 and 3 have only common factor as 1. Though 10 is an even number, 3 is an odd number. So our count is not based on even and odd, it is just based on HCF, whether your HCF is 1. That's all you have to check for a rational number. Okay, like I told you here, surds also come under the category of irrational numbers. Apart from these kind of decimals, the other set is surds. Surds are something like this: root 2, root of 15, root of 48, so on. If you see, say for instance, root of 4 you take. Square root of 4 is 2. We know that. They are perfect squares, isn't it? Square root of 9 is 3. What about square root of 3 then? What about square root of 2 then? It's not 2. Definitely not 2. Definitely not 3. Okay? Don't think it is. So what I mean is, further there is no perfect square possible from a square root of a number. Then you can categorize them under the category of surds. Okay? Say not only this way, you can write square root of 2 root, say for instance 17, or I can say minus 7 root 3, and so on, like this. Okay, these are some examples for surds. Let's see the next topic about further categorization of rational numbers. So as I told before, rational numbers now further can be categorized into, rational numbers are represented with Q. Okay, these can be categorized into Number 1, integers and non-integers. You can call integrals also. Okay, non-integrals or integers. So these are the two categories we have. Integers form a set of, what are the integers? They should be negative, they should be positive numbers, and there should be a 0. 0 is neither positive nor negative, so don't categorize in any one of these. It should be negative numbers, positive numbers, and a 0. Correct? So rational numbers, if I categorize integers set which have numbers like, for instance, I make a set here, minus 11, minus 3, minus 1, so on. Not so on, here it should be so on. Okay, so on, from towards your left it is so on. Okay, now here if you find, you can see positive numbers which are like 1 comma 3, 2 comma 3 comma so on till infinity. Okay, and this 0, it exists like that. Now tell me something, 1 to infinity, these are nothing but natural numbers. Natural numbers can be written with letter capital N. Okay, and then if I include 0 and the natural numbers, it becomes whole numbers. So whole number set starts from 0, isn't it? 0, 1, 2, 3 and so on. So this is whole numbers with capital W. Okay, these are the negative integers. This come under the category of negative integers only. We don't change anything here. Okay, and then further, what about the non-integral parts? Non-integrals are, see, there is a condition for integer. Integer cannot be in the fraction form. It should be always like a number with either a positive symbol or a negative symbol. It can be 0 also. So non-integrals means, like for instance, minus 5 by 3, a non-integral. Minus 11 by 2, non-integral. Minus 7 is just an integer. Now if I make it like this, it becomes non-integral. Okay, so this is how. Something like this also comes under the category of mixed fraction. You can say plus 2, 1 by 3. Okay, 7 by 9, plus 7 by 9, something like these numbers all come under the category of non-integrals. Rather than integrals, they come under the category of non-integrals. Okay, just make it neat. Come on, plus 7 by 9. Imagine all these numbers are non-integrals. So for an integer to exist, it should be either a negative number or a positive number or a 0. There is no fraction form. There is no numerator denominator form for integers. If it is so, it is non-integrals, and they can be positive, negative, and they come under the category of rational numbers as well. Now how do you represent integers? Integers are represented with capital I or capital Z. Why capital Z, ma'am? Because I's, it makes sense, it's integers, so we make sense it is I. Although here rational numbers is Q, of course we already use this R for real numbers, so don't get confused. Real numbers is R, please don't make mistake here. You need to know these. Why should we learn about these letters is, when you are solving parts of like sets, when you are solving integers, when you are solving for differentiation integration, which you will get much later in your higher classes, you need to know the sets. Even in your 10th grades or 9th grades, you will find how to represent the number line, linear inequations topic and all. You have to know the real number set. If you don't know the representations, it becomes a little difficult for you to analyze the question as well as write the answer, or you may go wrong with the answer. So we need to know it. Okay, so that's the purpose we are learning all of this in this session. Okay, right. And then, so integers are represented with I or Z. Z stands for, Z is actually Zehlin. So he is the person's name. He did most research on integers, so it was given his name, his letter. Okay, Z stands for Zehlin. So that's why I or Z represent usually the integer set. Okay, let's continue in the next class.